Okay, so back at them. What we're going to look at now is we're going to look at a couple of relatively simple applications for you, but common. The first one's going to be a V-block problem. So if you're working with a piece of round stock, you need to drill a hole through it or whatever. Let's say you got, I'm going to try to make this look like a circle. I'm not going to do real well at it, I guess. So we have a piece of round that is a 2-inch diameter, and it's going in a V here that is 70 degrees. I'm going to give you that the height from here to here is 1 3/4 inches. The total height is 3 3/4 inches here. I want to know how far this round piece sticks up above the top of my V block. Finding the triangles is going to be a little more difficult here. But we can find, first thing we need to find is just anywhere where we can make a right angle. One thing we know about circles is when there is a tangent to a circle, that forms a right angle with what? With the radius of the circle to that point of tangency. So I know that there is a right angle on each side of that circle where it is tangent to the sides of the V. I also know that if I connect the center of the circle to the point where those two tangents intersect, that it cuts the angles in half. So this angle here is now 35 degrees. So I'm going to redraw that triangle there. This is a right angle. This angle is 35 degrees. Do I know any of the sides of that triangle? I know one. This is 1 inch, radius of the circle. Now what I'm interested in, I'm trying to find heights up and down. So I'm interested in this side right here, which is the hypotenuse. Which side is the 1? That would be the opposite. So I am dealing with a sine opposite of hypotenuse. So I put in my angle. Sine of 35 degrees equals 1 over the hypotenuse. So to find the hypotenuse, I put this over 1. 1 times 1 is 1 divided by the sine of 35 degrees. Gives me 1.743 inches for the hypotenuse. So this is 1.743 inches. Or from here to here, 1.743 inches. Any questions so far? Yep, all I did here was 1 times 1 divided by sine of 35. So 1 times 1 divided by sine of 35. So I'm going to change this 1 3/4 to 1.75. So I have 1.75 gets me to here. 1.743 gets me to the center of the round part. I still have to get up to the top here, which is how far? 1 inch. So I'm just going to add those up. 1 plus 1.743 plus 1.750 is 4.493 inches. But I want to know how far it sticks up above. How do I find that? You bet. Subtract that height, which is 3 3/4. So subtract 3.75. 0.743 inches. What do you guys think? Could you handle that? Yeah? Well, not like immediately, but I'm sensing a slight lack of trust there, Mike. In your notes, find that same height here. The height that is above the top of the V-block. Anybody get an answer yet?
Yeah, I think so.
What'd you get? 0.440. Let's see how this goes. So we're going to do this and cut this in half. So what we have is this triangle, right angle here. This is 20 degrees, and this is 0.75 inches. So we are going to be dealing with the sine of 20 degrees equals 0.75 over, I'll call that y for now. So I put this over 1. It is 1 times 0.75, which is just 0.75, divided by the sine of 20 degrees. So 2.193 inches. So this is 2.193. This is, of course, so we have 1.5 plus 0.75, because that's the radius from here up, plus 2.193 gives us 3.443. And from that, we subtract. What's that? Should be 4 points, shouldn't it? Yes. And from that, we subtract 4. You get 0.443 inches.
You want us to go 3 decimal?
Yeah.
How many decimal places?
Two decimal places on angles and 3 decimal places on lengths. What do you think?
Todd, can you go back and explain? No! Hey, Drew, I wasn't talking to you, thank you.
Explain what?
I was just answering for her.
Oh, okay, thanks. Just down here. Why? Oh my gosh.
You've got 1.5 goes up to here, right? 2.193 goes up to there. And then the 0.75 is the radius up to the top. So that's all we're doing is adding up those dimensions to stack them up for height. From bottom to top. Does that make more sense? Perfect. So on this one, let's say this is 244 feet. This angle up here, 75 degrees. This 345 feet. This is a right angle here. and I'm going to give you this distance here is 400 feet. I want you to find this angle for me. I want you to take a second and try to dirk it in your notes, and then we'll go over it in a second. Anybody have any ideas? Okay, obviously we can cut this and make a right triangle here, but we don't know, we know that this is 244, but we need to have another side to it somewhere. We either need this side or this side in order to find that angle. We have to have two sides of a right triangle to find an angle. So we are going to go ahead and cut this up here. That is 75 degrees. Do I know any of the sides of that triangle? I know that's a right angle because I made it that way. We can find this side, which would be 345 minus 244, which is 101 feet. Everybody see that? Which means I can find this side. According to this angle, this would be the opposite side. This would be the adjacent side, so we are dealing with a tangent. So we're going to put in the angle, 75 degrees. The opposite side is what we're looking for. The adjacent side is 101. So this is tangent to 75 times 101 divided by 1, but I don't need to put that in there. So 376.94. So what does that mean? That means this distance is 23.06 feet. Now that we have that distance, if we're looking for this angle, we have the opposite side and the adjacent side. The tangent of an angle equals opposite over adjacent still. We're going to go ahead and put in what we know. We are looking for the angle. We have the opposite of 244, adjacent of 23.06. We're going to have to do an inverse tangent. So second tangent, 244 divided by 23.06. 84.660 degrees. What do you think? Totally doable? Why not? Let me try that again. So find this angle right here for me. What'd you find? Everybody have it yet? What'd you get? 62.35, you're saying? So let's see here. We're going to cut this at a 90-degree angle. This we know is 100 feet up here. So to find this, it's going to be the tangent of 61 degrees is going to be, we'll call that y over 100. So it's just going to be the tangent of 61 times 100. We don't have to divide by the 1. So that's 180.405. 180.405 feet. Which means when we cut this, this is going to be 209.595 feet, correct? So this is going to be an inverse tangent, second tangent of 400 divided by 209.595. $62.35. Very good. Anybody get something different? Not sure why it's different? Okay, well, in your book, on page 760, there's problems 1 through 15 there. If you want to just do the odds to start off with, but even the evens have some really good applications in them for you. Give those a shot. These are ones where you're going to have to search a little harder to find your triangles. We'll discuss them more on Thursday.
But did you get the second triangle? I got the 180, but 400.
390 minus 180 gives you this.